everyone. Good morning, wherever you are. I hope you had a good day and I hope you've ticked off majority of your to-do list. From my side, yet left the agenda, and the agenda is making sure you guys have an awesome webinar on Power BI. So today, we'll be talking about Power BI training, and also I'll be able to give you a small insight on what is Sibasi, on who we are. So in Sibasi, we deal mainly with development, deployment, and consulting. So we are a consulting company mainly on Microsoft product solutions or any tech-related thing that you like. And we also offer development in terms of software engineering, both concerning mobile apps and also web systems. So on today's webinar, we'll be talking more about Power BI, and the training will be led by our Power BI expert. Her name is Didi Kashema, and she'll be telling us how can we perform modeling on Power BI. So some ground blocks. If you have any questions, you can drop the questions via the Q&A area. If not, please feel happy to stay with us during the webinar. So Didi, it's up to you. Welcome.
Thank you, Mandela, for the introduction. I'm going to jump in quickly and say this is part of a series called Power BI Training, and we're on the last part, which is part 3. If you missed the previous trainings, we covered the first parts. We covered Power BI introduction. We went through modeling data in part 2. We learned how to shape data, clean it, and make it model ready for visualizing and giving the correct data. So we left the last part, which was DAX and the security in sharing the reports internally. So we'll have the link shared to the people who didn't have it previously. All right, so for today's session, we've already covered the introduction. We'll go straight to DAX. We'll see what is DAX, the concept, syntax, and the functions. Then we'll jump right into security, and we'll see RLS, what it is, how to create it, and managing the demos. The roles which we'll see covered during the demo. Okay, so the first, the big question is, what is DAX? So DAX, in simple terms, it's data analysis expressions, and it's a formula language. So you find most times you import your data into Power BI desktop, and without having any manipulation, you can immediately start creating reports the way it is, without any functions, any high-end formulas and stuff. But sometimes, as much as it doesn't restrict you in presenting the data or doing the interactions, using the build through feature, sometimes you want to include out-of-the-box formulas that don't come with the data. That can be the year-on-year sales growth, or you might want to run totals based on monthly sales, or perhaps you want to predict profit for next year. All of this can be achieved using DAX. So you find you want to, DAX formulas help you to find insights that you want to extract from your data to make it more useful. So basically, it's using new information that didn't come pre-built with the data. That's basically why we need and use DAX. And throughout the whole training, we'll frame our understanding of DAX around 3 fundamental concepts. We have syntax, functions, and context. So there are other important concepts in DAX, but understanding these 3 concepts will provide the best foundation on which you want to build your DAX skills upon. Jumping to syntax, we have this on the screen. You can see it's a formula which includes the following elements. So we have the A part is the measurement, which in this case is total sales. And we have it are just right before the equal sign operator, which indicates the beginning of the formula. So if you've used Excel, you see we always use the equals first before we do any formula there. And it means it will calculate a result of what you're trying to, of what you have named. So the C part is a DAX function. It's called sum. It adds up all the numbers in the sales amount column, which you can see from F. Then we have the parentheses. This is around the expression that contains the argument. And most functions require at least one argument. Like here, we only have one, which is the sales amount. Then we have E. E is the sales. Sales is the table which is being referenced. And we have F, the column being referenced inside the table. So with this argument, the sum function knows which column aggregates the sum on. And like we said, although this is the same as just simply dragging the sales amount column to the report, it's good practice to always create your own measures so that you can create a reference in other formulas that you create later on in the report. The second bit is the functions. So functions are predefined formulas that perform calculations on one or more arguments, and they always reference a complete column or a table. So if you want to use only particular values from a table or formula, you can add filters to the formula. So we have a number of DAX functions. We can summarize them into 10 formulas. We have the time intelligence, and with this you can create calculations using dates and time ranges combined with abbreviation. This is specifically useful for building comparisons across time periods. Then we have the filter. The filter functions, you can return specific data types, look up values in tables, or filter by related values. The functions work by using tables and relationships between them. We have the information. These functions evaluate a table or a column provided as an argument to another function and inform you if the value matches the expected type. So we have the if blank, is error. It gives you info more on what you're trying to evaluate. Then we have the logical ones. So this one's return information about the value in your expression. Then we have the math and trig. These are very similar to the mathematical and trigonometric functions in Excel. So math and trig functions perform a wide variety of calculations. Maybe you want to round up a number, round it down, sum like we've seen, or in a currency, degrees, converting the numbers into different things. Then we have the other, like we have a type of functions called other. They don't fall into any of the predefined categories, but they're also unique in their own ways. These are like except, if you want to group by, maybe union, var, for creating a variable, and so on. We have the parent and child. These functions work on data that is presented in a parent-child hierarchy in the data model. So we use path that contains to trim down to relating things. Let's say you have a manager who has someone they're reporting to, and they also have somebody they're reporting to. You can be able to trace the lineage of the parent-child hierarchies. We have statistical. These functions are used to perform aggregators such as the sum, the mean, the max, the average, and you can filter a column prior to aggregating and create aggregations based on related tables. Lastly, we have the text functions. These operate on string values. You can use them to search for text within a string, or concatenate, or find, or the length of the string, or convert it to uppercase, lowercase, and so on and so forth. You can also trim to remove white spaces and line spaces in the text. The last DAX function is the context. So context is one of the most important DAX concepts to understand. We have two types of context in DAX. We have the raw context and the filter context. So for the raw context, you can think of raw context as the current row. When a formula includes a function that uses filters to identify a single row in a table, we consider this a row context. So the function applies a row context to each row in the table to which the filter is applied. So this is what we usually use in measures, the row context one. And the filter context, this exists in addition to the row context. So a filter context is one or more filters applied in a formula, in a calculation, which determine a single value or results. So you can use a filter to reduce the values that are included in a calculation. By base, maybe you have 10 categories of product that you only want to filter 2 or 3. So a measure, let's say if you only have a measure that has sales amount, it includes everything. But once you have filter, you can filter, don't give me everything, just filter only where it's a specific thing. Yeah. Then we have now the columns, the calculated columns and the measures. So the columns are, we use them to add columns to any table in your model. That's wasn't existing based on a formula. Then we have the measures. You can write a DAX formula to add a measure to any table in your model. So the formula is concerned with achieving summarization of a model data. So the same to a column, the formula must return a single value, but unlike the columns, which are evaluated at data refresh time, measures are evaluated at query time, so the results are never stored in the model. Then occasionally you might find measures can be either described as explicit or implicit. So explicit measures are the measures that are written in DAX, and the implicit ones are the ones that are columns that can be summarized by visuals in simplistic ways. So you might find you have a number column and it comes already summarized. So it can, you can either have the average, the maximum, minimum, count, sum. So any column that can be summarized in the most simplistic way possible, we describe it as an implicit column. And to see them, they usually represented by the sigma symbol. So you might find some columns, like let's say the unit price discount percentage is not having does not have the sigma function, but it can also be summarized in a data model. So we find people asking, why don't we refer to measures as calculated measures? Because we leave the word calculated to describe the tables and the columns, which helps distinguish from tables and columns that come from the Power Query. And yeah, so we can quickly jump to a demo to see how we can use DAX in our Power BI reports. Okay. So it's a simple report that we can see has a number of things happening to it. For instance, we have the total sales. This can as easily be from the sales table. We can the total sales amount. We can drag it down and we can have the same number as a measure. And like we have said, we want to learn how to create our own measures to be able to use them in arguments. So in this case, you can see having this drag down gives us the same number as a measure. So here in the measures table, you can see we have a total sales, which sums up the sales amount table. This is the same formula we saw in the the presentation, we have the total sales, which equals to a sum of the sales amount column in the sales table. So these two, they're basically the same thing, but we don't want to be lazy. We want to learn how to create our own measures for the sake of putting them again in other arguments. So you might find you want to calculate a measure to include another filter. So in this case, you might have it computers. In this case, you can see we are saying, see if we can see my screen correctly. But here we can see the total sales computers is equals to, we calculate, this is a filter function, total sales. It's the measure you created, but we're filtering another table, which is also the two tables are. So remember we said for a filter to work, the tables must have some kind of relationship. So we are saying from the sales table, go to the product category table and filter only where it's computers. And that we can see gives us a sum of that amount. So if I put it here, maybe here, and I put it as a card, we can see out of the sales amount, this much came from computers. So you might see you want to filter your data based on a specific thing. That's when we now use the filter context measures now, not the raw context ones, because this can bring in every single thing. And you can use this also to create more reports from it. Then we have the time intelligence one. Like we said, you might want to so I'm going to focus more on this. So here you can see we have the table and it has the country, the total sales of the computers, and the revenue year to date. So all this we've created using DAX functions. Like we have the revenue year over year. You can see we have other functions called var. This is a variable which we assign it to a measure called revenue per year, and we can calculate the total sales of the same period last year. So you can see these are not easy to create without having to use DAX. You cannot get this function if you don't employ some of the, or borrow some of the DAX functions. And so with this, we can bring in the year-over-year comparison by totally just using DAX. And if we put it on a table, we can see all the comparisons. So and drag it, can drag it still. Okay, so we can. Since we need to rethink our modeling, but basically we can do it correctly with having the year to date and the year-over-year percentage on specific things. Yeah, and we can also have more. Maybe you'd want to have revenue per year. You can do the same thing per year by doing the calculate the same time last year, or the year to date, the same way you can create using DAX. So there are a lot of DAX formulas that you can employ, and you might find it's not very easy to learn everything on the first try. So always think about what you're trying to achieve. Maybe you might want to see, I want to return a table that has this. That means you want to return all except. So if you come to the DAX documentation, you can find all the functions that we've talked about. And depending on what you're trying to achieve, you can be able to see, maybe you want to achieve, let's say you want to round down a number. You can see it rounds down the number and tells you, first it gives you what it returns. So it says rounds the number down towards 0. And here you get the syntax. The syntax says it's a round down, you give it a number and the number of digits you're trying to achieve. And if you go down, they usually have examples. So you can see if it achieves what you want. Maybe you have this 3. Maybe this is like pi 14159, and you only want it to do decimal place. So it rounds it down to 3 decimal places. So it will have 3.141. That will be the result. So basically, there's no shortcut to knowing all the DAX in the world. It's more of a need to know basis, depending on what you're trying to achieve based on your business needs. You might want to have time because maybe you want to see what was your closing balance in the year. You come and see if it gives you what you want. So it gives you the what do you call this? The reason. So it explains what it does, the syntax, the parameters explain, the time values, and it gives you an example of what you're trying to achieve. Yeah. So there's a lot more to cover. I think it's cannot be a one video thing. If I was to go through each and every one of them, so I leave with the idea of depending on what you're trying to achieve, the documentation covers it all very nicely. All right. So jumping on to our presentation, we can go back to row-level security. And what this means is, I'm sure you've heard the RLS being done around most times by people doing analytics. So it basically means row-level security. And it enables you to restrict the data a user can view based on certain filters you've put in place. So these filters work at row level to control what data is returned to the user and can be managed using roles. It doesn't hide the columns. So as long as if you have 50 columns, you don't restrict the number of columns somebody can see, but it restricts the rows based on what you've set in place. So it could be you want people who are working maybe in finance to only view finance stuff. So you put them in place. And we have two main types of RLS. We have static and dynamic. So static is the simpler one of the two, and it requires just a normal Power BI developer to define security-based logic manually within the PBIX file. And the dynamic one is a bit more complex because it needs it requires logic to be defined within the file and the data model using relationships. So you might find you have a table which has all your users and their UPNs. That's the principal names. So you're saying based on who's logged in, show them what they're supposed to see. So you've already predefined them on a data set somewhere else. Maybe you want specific users to have access to finance, so they're already predefined. So once they're logged in, the user can see this person is from this list, so they can be able to see this list. So it's a bit more complex, but it's not very hard to set up. We have the use cases for different levels. So it's important to have this in place in an organization where they value data security strategy. By implementing this, the organization can ensure each Power BI report user has the appropriate data visibility. And without this in place, end users can see what they shouldn't have access to, e.g., the payroll or sales data, which can cause unforeseen issues for your organization. So we have different use cases. Maybe one can be location-based. In this case, we want your user to only see information within a specific location. So it could be a state, city, region, country. Maybe you're the head of the finance for the Eastern region, and you should only see data for the specific area. Then we have employee-based. So here we want a user to see information that they're tied to or responsible for. We don't want maybe people seeing other people's goals or what they have in the pipeline or what they're trying to close and deal. So here we restrict what an employee says based on who they are. We have the baseline, which is the business baseline, where you want a user to see information within a specific business line. Maybe it's a department, a service, a product, a division, or a unit. And we have the last one, job title, which I think is speaks for itself. if you're a CEO, you only see CEO staff, and if you're a normal title job title holder, you say what you have. So you might ask yourself, when do I then decide how to use static or dynamic? So if you find you need to restrict data visibility for a specific group of users that require the same level of information, then you use static. Maybe you're a regional sales team and you want to view only your specific region data, then you can now have this. Also, if you don't have a lot of users in your organization, very few users, it's easy to manually just point them on what they should be able to see. Then if your logic is high level and straightforward, e.g. just by user, by company, or by region, then also if your user requirements remain stagnant, that means security groups and security group users will not change frequently, then use static. And if you don't add or remove users frequently, also it's key to use static. Then for dynamic RLS, it's just the opposite of the static one. So if you have if you change your users frequently, or you have a huge number of users, or you want people to see different levels of information, and your logic is a bit more complex, then you utilize now the dynamic one. So we have a few limitations on using RLS. So the first one is you need to be in Power BI Pro subscription. Two, you cannot, the roles and rules you create in the desktop are in the service, you need to recreate them in desktop. And there's a move to have all the roles being done on the desktop side and then pushed to the service side. Then we have, you can only define them on datasets made in Power BI desktop. And you can only import data in direct query connections. Those are the only supported ones. And live connection to SSIS, that's the analysis service, are handled on the on-premises data model. So I'll quickly jump and show how to create the row level security. So you might find in your data here, you have different countries, and I want to restrict people to view people from Greece, you should only see Greece, and France, you should only see France, and so on. So you go to modeling. So you go to modeling, and under modeling, you select the manage roles. And here you can create permissions as you want, as you wish. So you can create a new role, maybe call it France users. France users. And you say from France users, I want to filter the geography table. You add your filters from here. And using the country name, you see where the value is France. And you save this. So you can see as of now, you can still see everything, but you can also test to see how the user will see the data once they log in. So you can view as, and you say, I want to view as France users. And if you do that, the report filters to show you only France. So you can do this for different things. Could be products, could be, it depends on what you're trying to filter, and please ensure that your data is well modeled. You have all the tables well connected, because if you make one small mistake in the modeling side of the relationships, you will not have the right data once it's filtered. So you can have the same thing also using the users. So in this case, the developer will create users and their details, then link them up based on who's logged in. So think for the sake of this presentation, we'll only leave it up to that. Yeah, and that's more or less all on security and understanding the basics of DAX. Yeah, and I'll jump to in case of any questions.
For my side, I can't see any question on the chat, so I think you're good to go. You can go on.
Yeah, so I hope this gives you a high level of how to maneuver security and how to create and work with DAX.
Okay. Thank you, Didi, for the session on that. I think it's one of the most interesting thing, and one of the key takeaways I've taken is that DAX is a language used to create custom calculations in Power BI. I can't remember how you created the locations. Yeah, and also when it comes to security, that was quite interesting. So thank you guys. That was the session for today. Remember that Usibasi always has Microsoft Wednesdays, and see you next time, same place. So we'll share our link to our Eventbrite, and you can follow us for more sessions. If you want any personalized training, kindly reach out to us via our email. Thank you. Bye.